Hello and welcome to Algebra 2, Chapter 9.4, and today we're going to discuss multiplying and dividing rational expressions. Remember, these are fraction expressions. Okay, so to begin with, a little review of just simplifying fractions. If you have a product on top and bottom that have the same factor, so here C is a factor of both, those C's can be crossed out and what you're left with is just A over B. Notice it has to be a product. So if you look at 4/6, so if I write 2 times 2 over 2 times 3, that still says 4/6. If I cross out those 2's and I get 2/3, does 4/6 equal 2/3? Okay. Now at the same time, just to show you what not to do, I can write 4 as 2 plus 2, and I could write 6 as 2 plus 4. Okay, that still says 4/6. And if I crossed out those 2's, then I'd get 2/4, which is a half. And does 4/6 equal a half? It does not. Okay, so you can only cross out common factors if it's written as multiplication, which means that we are going to have to factor everything. Alright, so to start out with, we just have one fraction and we want to simplify it, okay? You cannot, I repeat, cannot come through and cross these out. Okay? I just showed you on the last slide, that will give you a different answer, that you cannot do that. You have to factor this. And I factor right where the problem is, so I'm going to factor the bottom first, just because it's a difference of squares and I saw that. So there's the bottom factored. I'm going to factor the top. It's x minus 6, x plus 1, because that's what gives me a negative 6 at the end and a negative 5 in the middle. And then if there's any common factors, you cross them out now, because I'm multiplying, and you write what you have left, x minus 6 over x minus 1, and that's your answer. Okay, so stepping that up from just one fraction to now we're going to multiply. There's two different scenarios you can have. This one all has monomials everywhere, so there's no factoring to actually do. And so I'm going to do two different problems like this and show you two different ways. So the first way is going to be just multiply straight across and get one answer and then reduce it. So that's how you multiply fractions straight across. So I'm going to have 60. This is when you got to remember your exponent rules, that I'm going to add my exponents when I'm multiplying over 36x squared y to the 4th. Okay, so it's a total answer. Now what I have to do though is I have to simplify that. So I'm going to go, okay, well 60 and 36, 3 goes into both of those. So 3 goes into this 20 times, 3 goes into this 12 times, and then I can do, I probably should have done 6 to begin with. I don't always think that far ahead. So if I do 2, I'm going to have to go again, aren't I? There's 2, and then we got 2 again. So how about 5 and 3? Alright, so we get 5/3. And then when you are dividing, you subtract your exponents, so that we get x cubed, y cubed, and they both are on top because they both are going to give you a positive when you subtract. So that's one way to look at just multiplying all monomials together. The other way to look at it, which might look really confusing after the other way, is that you can reduce before you ever multiply. So I can say, I always start with my numbers. So 9 and 27, 3 goes into both of those, so that becomes a 3 and a 9. Okay, because 3 went into both of those. And then these 3's are going to both cancel. And 3 is going to go into 12 and 9, and that's going to become a 4 and a 3. And so now my numbers are completely simplified. And then I'm going to look at my x's. And I'm going to say that these 2 cancel with 2 of these, leaving just 1 there. And that's all the x's that can reduce. And then y's, this is going to cancel with this to become a 3, but then that's totally going to cancel with this one. Okay, so on top we have a 4, and then I'm just going to circle them so you could see them better. We have this 1x and this x to the 4th, so we have x to the 5th. And we have this y, so y over 3. Okay, and so it is a little messy, but you just get to the answer by simplifying everything before you multiply. And if by chance you get to that part and you still had something in common, you would just simplify again. So moving on now to actual polynomials as part of these fractions. And you're going to do exactly what we did in the first one. And then when you just had one fraction, is that you're going to factor first. Okay? You do not want to multiply these together. That's going to give you a headache. First of all, to multiply these together and then to have to simplify it, because our whole goal is we want the simplest form of our answer. And if you multiply these together, you're going to end up with like x to the 5th, and you're going to have no idea how to break that down. You're not going to want to break it down. So do not multiply these together. Factor everything. So if I start here, you know, however you factor, whether you factor by trial and error or you factor with what's called the AC method. Let's see here, x minus 1 plus 1. That's a negative 3 plus 1 would be negative 2. This one up top has the greatest common factor of 3x, which is going to be 1 minus 9x squared, which happens to be a difference of squares. 1 minus 3x, 1 plus 3x. It's kind of backwards, but it's a difference of squares. 3x and x minus 1. Alright, so everything is factored, so that's the first step. You know, and so up on the top left here, you know, we don't have this one anymore. What we have is that one. I like to work right above it. If you want to totally write it out separately someplace, you're welcome to. And so now you cross out everything that crosses out. So for instance, that 3x cancels with that 3x. X minus 1 cancels. Forgot to print this up here. 3x plus 1 is going to cancel. So 3x plus 1, this is also a 3x plus 1. It's just written backwards. Those cancel. Okay, and so I think what we have left now, at the moment, you might write it like this. So first of all, whatever you have left, you're never going to multiply together unless it's just monomials. You're going to leave factored, okay? But what we need to see here, though, is that these are the same thing if I would pull a negative out of one of them. If I pull a negative out of this, it's going to switch it to be that. Because there's my negative 3x and my positive 1. Okay, so if you can see that. And then I have the other one still. And so then what I can do is I can write my answer as negative quantity 3x minus 1 squared. And that's my answer. Don't FOIL it out. You don't need to FOIL it out. Okay, so let's look at another one. So this one, our second one, would just be over 1 if it's not over anything else. So we have x plus 2. That can't be factored. Let's see here. 3x. I wonder if this is a difference of squares. Or not a difference of squares, sorry. Perfect square trinomial. If it is minus 2 would be, nope, because it's negative 6. That is not. So let's actually come down to this other one here. This is a sum of cubes. And if you haven't factored a sum of cubes in a while, let's see here. Sum of cubes, if you have a cubed plus b cubed, factors into a plus b, that quantity, times a squared minus ab plus b squared. Okay, definitely have these written down. You can also factor a difference of cubes, and it factors in a minus b and then a squared plus ab plus b squared. So all the a's and b's are the same. That negative just switches to the first binomial. So I know this is a sum of cubes because this is 3x that's being cubed. That makes 27x cubed. And this is 2 that's being cubed. And if I can write it like that, then what I just found was my a and my b, and I can come up here and put it into the form. So this factors into 3x plus 2, that's a plus b, times a squared is going to be 9x squared, minus a times b is 6x, plus b squared is 4. And so the reason I could not factor this up here is because it matches this down here. It's just something that's not factorable. So if we look at what crosses out then, those cross out, and what we're left with is x plus 2 on the top and 3x plus 2 on the bottom, and nothing else cancels because you can't cancel when you're adding there. That's our answer. So moving on into division, when you divide, there's just one extra step, and you're going to do it first. And remember, to divide fractions, you multiply by the reciprocal. And you have to do the reciprocal of the second one. Okay, don't do the reciprocal of the first. So the reciprocal of the second one. Okay, so again you factor. So if I look here, I have a greatest common factor. And up here, this would be x plus 3, x minus 2, negative 6, positive. All right, and I got a greatest common factor down here. So still you factor everything, and then you're going to look to see what crosses out. So we get x plus 3's, x minus 2's, and we are left with 3 over 4x. Alright, so let's look at another division one. So remember, you have an extra first step, and that is you need to switch it to be multiplying by the reciprocal of the second one. So we keep the first one as is. This is over 1, so we're going to times this by 1 over. From there, we factor everything. So this has, let's see here, not a greatest common factor of 4. Let's try again. How about a greatest common factor of x? Plot an x. We are going to have 4x minus 1. And kind of let that help you factor up here. Because remember, 8x squared could be 4x and 2x, or it could be 8x and 1x. So I'm going to try 4x and x, and let's see if this happens to be a minus 1. If that's minus 1, that's plus 3, and there's a 12. Nope, that's not going to work. Oh, because it has to be a 2. There we go. So there's 12 minus 2, which is 10. Perfect. Alright, so everything's factored, and then we're going to cross out the like factors, so the x's are gone. That looks to be it. So I think our answer is 2x plus 3 over 4x cubed. Alright, and one more example, and so this one is multiplication and division, and you can do it the exact same way, and in fact we might find it easier to set it up all at once. And so I'm going to rewrite my first one, and no need to factor there. My second one, and that's over 1 if you want that over 1. The third one is going to be times x plus 3 on top, 16x squared minus 1 on the bottom. That is a difference of squares, so it's 4x minus 1 and 4x plus 1. And then all the way across, you're going to cross out like terms. So there's x plus 3's, 4x plus 1's, and you are left with x on top and 4x minus 1 on the bottom. Alright, so there is 9-4, multiplying and dividing rational expressions, and 9-5, we're going to go on into adding and subtracting them. So remembering that we need a common denominator. And if you have questions, let me know. If not, I will see you in class. Have a great day.